In this little thing, we are going to look at relative velocity in one dimension, and the big idea that I want to focus on here is that the relative velocity of an object is equal to the velocity of the object plus the velocity of the medium in which the object finds itself. So, for example, if we have, say, a boat, here's a boat, okay, little guy on there, he's, got a paddle or something. It's a magic transparent boat. Okay, so this boat will be going forward. However, he's in a river. Okay, there you go. And he is going directly upstream. He's literally paddling directly upstream. So here's the idea in how you should really think about this. We want the velocity relative to something, okay? So there are a few different ways to think about this. We're going to go first with the most useful one, which is the velocity relative to some guy who's, say, standing on a rock out here. There's like a rock, and here's somebody standing on the rock watching this happen. This dude is stationary, and he's watching this go on. What is the motion like relative to that guy? Okay, so here's the deal. The boat has some velocity. The boat is the object. Call it 2 meters per second. This is the velocity that the boat would have if it were on a lake with no current whatsoever. All right, if we were to take this guy, take away the river, put him out on a lake with a paddle, he could paddle the boat at 2 meters per second. That's what we mean by the velocity of the object. The velocity of the medium, that's the thing the object is in this case, that's the river. So the river is flowing at, say, 1.5 meters per second. I'm just making these numbers up. So the boat is headed to the right at 2 meters per second. This is velocity, it's directional, to the right. The medium here is moving to the left, which we've illustrated that with our arrow, at 1.5 meters per second. We now have a relative velocity problem. So if the question were like, how long would it take, there we go, would it take to travel, we'll just keep our number, to travel 10 meters upstream? Okay, so we can answer this question. We know that, well, what I've told you is that the relative velocity, VR, is equal to V object plus V medium. Okay, so we can fill some stuff in here. We know that the velocity of the object is 2 meters per second, plus the velocity of the medium, and looking back, it's 1.5. There's something very important here. It's 1.5 meters per second in the other direction. These are in opposite directions. The river is working against the boat and holding it back. So really, for every 2 meters the boat goes forward, the river carries it back 1.5 meters. So relative to that rock, this guy is actually only making 0.5 meter per second of ground. We can now carry that forward to actually try to answer the question. This is a constant velocity problem. So I'm actually going to go with this graph. I really like the velocity time graph. So we have a guy traveling with constant velocity at 0.5 meters per second. The question we're trying to answer is that how long, at what time, we're trying to find this value, at what time will he have traveled 10 meters? Well, we know that the area under a velocity time graph is displacement, so we can write an equation for this. Displacement is this area, that's a rectangle. We know the height of our rectangle is 0.5 meters per second, and the length, we don't know it, but we've created a variable, is some time. So that's our generic, for this rectangle, but we also know the distance we're trying to accomplish. We want the displacement to be 10 meters. So 10 meters, at what point will the area of that rectangle be equal to 10? Divide both sides by 0.5, and we find that t had better be equal to 20 seconds.